All right. So for the first few times, I'll be making some videos from my office as well, and depending on how I feel about how the videos are, is whether I'll put them from the lecture theatre or from here. But essentially, what I'm going to do is go back over the original material anyway. So, believe it or not, we started off with adding fractions, and adding fractions, we want to revalue everything. We want to revalue everything we do, and adding fractions sits right there in our revaluing. It comes up everywhere, and I'll show you some examples of that. All right, so what is it about adding fractions? Now, with fractions, obviously, we can multiply fractions. So multiplying is a fairly straightforward thing to do. It's just your times table. So 1 times 1 across the top. 6 sevens are 42. Likewise, if you do the opposite of that, if we take a 6 and divide it by a 7. Now, we could go and talk a lot about the various aspects of the divisors and the multipliers and all of that. 1/6 of a seventh. Okay, so, but let's just get on with the process. So what we'll do here is convert this into multiplication. That means rotating those. And so we get 7 on top and 6 on top on the bottom. So 1 and 1/6 is the amount that we have when we divide a sixth by a larger quantity, a seventh. So all of that's fairly straightforward. It's just straight across the bottom and straight across the top. So that's good. Fairly straightforward. What about when we multiply pronumerals? Does it make any difference at all? Well, no. You want 1 times 1 on the numerator. A times D is AD. That's all it is. It just stays that way. All right, so it looks like adding fractions is the real issue. What happens with adding fractions that makes it so difficult? So when we have something like this, and I think I did this in the lecture. Come on, man, are you serious? You're going to add half a pizza, and you're going to get a whole pizza, and 2 halves make a 1. Now, that's a concept, I guess, but when we start looking at adding non-families together, we could do a third and 2/3, or a third and a third, and we could do that, but there's a limit to the intuition that evolves. So when we look at an addition problem, the first thing we do is we ask ourselves, are they of the same family? Now, if they're of the same family, it's a very straightforward procedure. So this is now not the graphical concept. This is the actual use of the idea of a common denominator. So because we've got the same family or the same denominator, we can write the sum this way. Now, that's worth doing, especially initially. So 1/3 plus 2/3, it matches our intuitive idea that it would have been 1. The important thing here is that we've stepped from 2 terms into 1. That's the part that we need to do when the denominators are not the same. So let's add a 1/4 and a 1/3. And how do we unpack this? Well, the first thing we notice is that the denominators are not the same. So that we can't just do this and step off into the next family, the next common denominator. What we also notice is that it's really hard to start if you don't have a particular strategy in place. Now, one of the things that I want to mention again is this idea of not changing a quantity. If we don't change a quantity, we rely on 1. 1's not changing 1, 1's not changing 2, 1's not changing 3, and so on and so forth. Now we could go right down and say 1's not changing 12, and we could extend that idea. 1 times some apple is still an apple. 1 times a square is still a square, and so on and so forth. So the other thing, 1 is my favourite number for this reason, because 1 doesn't change the quantity. So when we do our additions, what we want to recognise is that we're going to not change the quantity of 1/4, but it's going to look different. Oh, okay. So the first thing we do is we set about setting up a new family, and we just multiply the denominators only. Now draw your scaffolding, because 3 fours are 12. Always do your scaffolding steps initially, just until you get the hang of all of this. And then we ask, well, if we're going to multiply a quarter by 1, that won't change a quarter, it'll still be a quarter. And so I can have the confidence that I've added a quarter. So what do we multiply the denominator by? What we do to the bottom, we do to the top. There's our 1 in disguise. So we can take confidence that we're not changing quarter. It's still quarter times 1. It's going to be an equivalent, but it's just going to look different. So 3 fours are 12, tick. 3 ones are 3, so we can put that over there. What do we multiply the 3 by to get this 12? It was a 4. And so what we do to the bottom, we do to the top. And there's our 1 in disguise. So 4 ones are 4. And so what we're able to do then is draw this step, 3 plus 4. Now, for so many of you, this is not something that's gone in. Okay, we don't need to get hung up on consolidating and simplifying all of that. That's okay, we can do that if we need to, but for the adding part, that's all we need to do. So how do we do that if it's a pronumeral? And let's just see. Let's do a 1 over c. So what we've got here is a problem in that we don't have any families. So we're going to set up the family AC, subtract, and the family AC. So there's our scaffolding. We don't want to change 1 on A, so we multiply it by 1. And we don't want to change 1 on C, so we multiply it by A. What you do to the bottom, you do to the top. So what we do is we get C and A up the top there. This becomes our paired family, C minus A. So that's the final result. So this construct is very helpful and comes up elsewhere. And so we have to be prepared to see it in other forms. Now, in actual fact, in the MRS, there was an exact question. I really don't know if I can get that quickly, but I will have a look and see if I can see it. And what's the result of the denominator over here? This is a product. So if we were to get something presented to us as a product on a denominator, is it possible that we could say, right, that is an example of adding fractions, the result of adding fractions. So let's have a look and see what we can see. Oh, that's interesting. Something happened there. Okay. Let's try one more thing here. And see if I can find this. There you go. Alright, so the dreaded MRS. So if we have a look over here and see if we can find the question that I'm referring to, what we'll find here is a question that's related to this very problem. Now, most of these are very straightforward. Some of you will be, that's not the one I'm interested in, but that's also a doable fraction question. This is the one I'm interested in. This one's saying, is it possible to recognise this p plus 2q r squared minus q squared? P plus 2q r squared minus p plus 2q r squared minus q squared. So what was being expected there was the form of the equation being recognised as being in process, if you like, for adding fractions. So in other words, the denominator was a family. So if we were going to go backwards for the family, then we would write r squared minus q squared and r squared minus q squared with a plus. And on one side we'd have a p, and on the other side we'd have a 2q. Now this is what this was asking you to do. It was asking you to cognate that this step was the result of adding fractions. And the information both in the denominator and the numerator helped to establish that. So when we go back to looking at this one here, this is the one that's of interest. The 2q is on the top in the separate term, so that's the one that we're interested in. So just a little thing of recognition of the quotient and how to change forms. So in our particular interest, we have our diary, and so in our diary we will be looking at, or our journal, we'll be looking at changing forms as one of our strategic intents. So if I quickly go and grab a bit of history here, I'll grab the blank again, just as a blank this time, and I might save this one, but for here what we wanted to recognise was our strategic intent. And in the strategic intent, have a bit of a thinner pen, we had a number of things, and among them included recognition and this notion of forms, changing forms. So this will help us build our intuition in understanding what it is that we see and how we simply make a substitution. So that's a changing forms issue there. Now, where that also comes in handy is in the process of integration. And it doesn't matter if you don't know what integration is, but some integrals will have a product on their denominator, and that can be viewed as, we can expand that and deal with that in other ways, but for this one here, what we want to recognise is that that is a family. And if we were to put that at the end of our sum of fractions, addition of fractions, then what would be before that? What would be before that would be both of the products separated. And when both of the products are separated, we know that it has linear factors on the bottom, which is a clue to the topic, but we don't know what the numerators are. And so what we do is we go about solving this, and when we do that, we get to a simpler, easier integration. Okay, so when people meet partial fractions for the first time, it gets quite complicated because they lose sight of, this is just adding fractions, and it's the process of going in reverse. It's this process. So the going in reverse process is the one that we're interested in. How do we join those together in that intermediate step so that they're a product? So it's a very interesting idea, but revaluing adding fractions. All right, and we'll do a little bit of gymnastics with adding fractions. One of the things that we can do here is that we can put together a little code, code 1, code 2, and essentially what it's saying is, instruction is move index out the front, and I can teach year 8 this, subtract 1 from the index. So we subtract 1 from index. Over here, what we want to do is add 1 to the index. Now, that in and of itself doesn't seem onerous, but What if the index is fractional? Move to the denominator. So a couple of simple examples. Okay, so 2 comes out the front, 2 minus 1, and so we get 2x to the power 1, which is just 2x. And many of you said, yep, all right, well, that's differentiation, that's great. Then I put up, what about the square root of x? So that has a different form. We'll go through that in a little while. X to the power of a half. So then what we've got to do is bring the half out the front, x and a half minus 1. And before you've even stopped to think about what's going on, you're having to deal with a half minus 1. A half minus 1, what's the form? Same denominator. And so we get 1 minus 2 over 2. And if you can do all of these steps, then you're set. Okay, 1, 2. So minus 2 from 1 gave us negative a half. So we have a half x, negative a half. So that little bit there is the bit that gets rushed through. So that if you're not really familiar with what's happening, it can be quite daunting. Now, I'm going to go through some indices in a moment, but essentially that's what we end up with. Same thing for this one here. If we've got, x2, up and under is going to be 3 over 3, and so that's the integration. All well and good, but what about if it's something like this? The square root of x again. Well, similar form, x to the half, and straight away what we have to do is x to the half plus 1. Half plus 1, so it doesn't go away. A half plus 1 this time is very straightforward. Same family. So we get 1 plus 2 over 2, and you should be the long way, just for a little while, just until you get used to it. 3 over 2, and then divide by 3 over 2, and so that'll become 2x to the 3 over 2 over 3 plus c. So what I'm demonstrating here isn't the integration and the differentiation, it's the technique of using the indices, and it has a certain amount of gymnastics. So a certain amount of gymnastics is a good algebraic gymnastics. So algebraic gym. Okay. All right, so for that one there, that was fairly easy to see that the skill of adding fractions is worth revaluing. It's certainly something that you would want to be able to do with some confidence. Certainly that is true. All right, let's have a look at indices. Actually, I might just press pause there, and I'll come back with it.